So, Chapter 12, Liquids, Solids, and Intermolecular Forces. I like this quote from Roald Hoffmann. It's a wild dance floor there at the molecular level. So, to start this chapter off, I'm going to show you this video of water in zero gravity. This is a Canadian astronaut on the space station doing an experiment proposed by some school children.
The question is, if you get a cloth dripping wet without gravity and you wring it out, what's going to happen? What will happen to a wrung out cloth? So, and had to use equipment that was here on board the space station. We may have the coolest washcloths ever here on the space station. I'm going to show you. Here's one of our washcloths. And it's packed in. It's put down into this little tiny hockey puck so that it saves space. But when you open up a hockey puck and you pull out your washcloth, this is the one I'm going to use for the experiment today. And so when you open up your hockey puck and turn it into a washcloth, it was compressed in a great big vise. Okay, so here's my washcloth, like a magic trick. And now I'm going to get this soaking wet, and then we're going to see what will happen when we wring it out. Meredith and Kendra suggested that I dip this in a bag, but bags don't hold water in space, so instead I filled a water bag. This has drinking water in it. And I'm going to squirt a bunch of water into this washcloth. Okay, so here's a soaking wet washcloth. Get the microphone so you can hear me while I'm talking. And now let's start wringing it out. It's really wet.
Isn't that weird?
The water's all over my hands. In fact, it brings out of the cloth into my hands. And if I let go of the cloth carefully, the water sort of doesn't stick to my hand. Okay, so the experiment worked beautifully. And the answer to the question is the water squeezes out of the cloth, and then because of the surface tension of the water, it actually runs along the surface of the cloth and then up into my hand, almost like you had Jell-O on your hands or gel on your hand, and it'll just stay there. Wonderful moisturizer in my hands. And the cloth doesn't really unravel itself. It just stays there floating like a dog's chew toy, soaking wet. Great experiment, worked perfectly. Meredith and Kendra, congratulations, great idea.
Any questions or comments? That's not how water behaves on Earth, is it? No. You can just kind of imagine those guys trying all kinds of weird things up there, right? Just to see what happens. Make a burrito? Yeah, you know, we really take gravity for granted, you know, it's like things keep floating away, and, you know, it's just some different problems in space. This is actually a photograph from the textbook, and that's the same scientist. Here he's got a big, I don't know, what do you call that? A drop of water? It's really larger than a drop. It's a piece of water, a large quantity of water, and it makes this big sphere. And so what we're going to talk about in this chapter is intermolecular forces and what causes water to do things like that. So intermolecular forces, as the name suggests, are forces that are between molecules. These forces exist between all molecules and atoms. They operate at short distances. They are responsible for the existence of solids and liquids. They are essential for physiological processes. We find that the state of the sample of matter, whether it's a liquid, solid, or gas, depends on the relative strength of the intermolecular forces compared to the thermal energy. And so we'll talk more about that.